Hello guys! Today we are going to learn how proteins act as buffer systems. So, the big question is, what is a buffer system? Well, a buffer system is something which helps us to control the acidity of a solution. And when we look at proteins act as buffer systems as well because they maintain the acidity in and our cells. So, if we look at the pH scale, we see that from pH 0 to 7, it is an acid solution, and from pH 7 to 14, it is a basic solution. And where do we find ourselves? What pH do we have? Well, humans have pH 7.4. So, then, if we analyze and get deeper into this, we see that if pH is bigger than the isoelectric point, it is a negative charge, and if the isoelectric point is bigger than the pH, we have a positive charge. And what happens if the isoelectric point and the pH are equal? Well, then we have an equal pH. How do buffers work? Well, they resist pH changes, and if you add an acid or a basic component to a solution, it keeps a stable pH. So, for example, a pH of 7.4. Buffers also contain a conjugate base and a conjugate acid, which then neutralize. So, what are proteins? Well, proteins are made of, each one of them, by many amino acids. And what is an amino acid? Well, an amino acid is an organic molecule that is made up of two parts. The first one is the amino group with the NH2, and then the other part is the acidic carboxyl group with the COOH. And then there is another part, which is a side chain called the organic R group, which is unique to each amino acid. And many amino acids altogether then make up polypeptide chains. So, if we get an amino acid and we break it down, we will have the carboxyl end in one side and the amino end in the other side, which this gives the amino acid the buffer property. So, in a reaction in which two or more molecules combine to form a larger molecule, there will be eventually a loss of a small molecule, which is in this case normally water. This is an example of a condensation reaction in which a new carbon-carbon bond is formed.
Oh, hello! It's someone there? Welcome, guys. My name is Little Timmy, and I am the first of the class in biochemistry. I hope this is not worrying you too much, because my teacher is the best of the world. Sorry, I'm a little bit cold, but I'm still going to class indeed. That means I am not understanding well the graph. Can you explain it better for us? I only see your head moving on the pen, going like mad. Thank you.
Okay guys, now we are going to analyze a graph related to the amino acid arginine. So, on the y-axis we have pH, and on the x-axis we have the concentration of OH-. So here guys, you can see that we have three lines. The first one is for pKa number 1, which is at 2, pKa at number 2, which is 9, and pKa number 3, which is 13. So, what is pKa? Well, pKa is the tendency of a group to donate a proton. And then we can see a green line. This green line is the isoelectric point, which is at 11. So, in the case for arginine at 11, the isoelectric point, there is no net charge, which means the protein or the amino acid is electrically neutral.
Thank you, miss, for the explanation. I'm now gonna get full marks in the next exam. Yay!
It is important to know how to calculate when a molecule is electrically neutral, or to calculate, in other words, the isoelectric point. So, how do we do this? Well, the isoelectric point equals pKa1 plus pKa2 divided over 2. The isoelectric point will have a higher pH when the basic side chain introduces an extra positive charge. So, the neutral form exists under more basic conditions when the extra positive charge has been neutralized. And then, when we have a lower pH for the isoelectric point, it is because the acidic side chain introduces an extra negative charge. It just works the opposite way. So, the neutral form exists under more acidic conditions when the extra negative charge has been neutralized. Here we have a red blood cell. We humans are made of millions and millions of red blood cells, and red blood cells are made up of hemoglobin, which is an amazing buffer. It binds to an acid in the blood, helping to remove it, so it can change the blood pH. In hemoglobin, we can find histidine, which is a great amino acid for buffering, and it is super important for us humans. The protein buffer system helps us to maintain acidity in and around our cells. So, hemoglobin is an excellent buffer, and it binds to small amounts of acids in the blood before they can alter the pH of the blood.
Oh, hello, my little friends. Here you are again. Let's go for the fun fact of today. Eating proteins such as eggs and so will help promote and maintain the amount of proteins made in your body.
That's correct, little Timmy. Well done. And this is the end, guys. So, a little joke just to finish. What do you call an acid with an attitude? Amino acid. I'm sorry for this one, guys. Thank you for watching and see you in the next video.